Hello everyone. Today we're going to look at balancing equations, and this is a very important thing for solving chemical problems. It's very useful in industry as well. The equation we've got up first is methane plus oxygen gives carbon dioxide and water. And before we actually start through the usual process, I just want to show you a couple of things about how to imagine what's going on. If you look at the formula for methane, it's CH4, and we can draw that like that with 1 carbon and 4 hydrogens. And the formula for oxygen, O2, we can draw that one as well. Sometimes it actually helps to visualize in maybe 3D what that might look like. So I've got these images for you. Here we've got the methane molecule. You can see carbon is in the middle and there's hydrogen sitting around the outside. And oxygen is a little bit more simple. We've got the two oxygen atoms attached to each other. Now, the products of this reaction are carbon dioxide, CO2, and water, H2O. And once again, I've got some images for you. The carbon dioxide molecule is a linear molecule. That means the atoms all line up. And you can see in this video how it's just got the carbon in the middle and the two oxygens on the outside. The water molecule is not linear. It's more of a V shape. The oxygen sits in the middle and the two hydrogens are stuck onto that. So let's have a look at how we can try and balance this up. The overall problem in balancing equations is to make sure that we're not creating or destroying any atoms, we're just rearranging them. So if we have a look at the methane, we've got, let's say, carbon first, okay? First of all, we've got some carbon here, and we've got some carbon here, one of each. Okay, so this carbon atom gets rearranged and it gets put into carbon dioxide over here. That's not a problem, all fine. With the hydrogens, we've got 4 hydrogens on this side, but we've only got 2 listed on this side. Now that is a problem because we can't destroy the hydrogen atoms. We have to find a way to balance up the equation so it actually corresponds to what's happening in real life. So if we have a look at the next slide here, you see I've actually drawn in an extra water molecule. Okay, there's the extra one there. So rather than just having one water molecule, we've actually got 2 water molecules. And that will help us balance up the hydrogen because now we've got 2 lots of water molecules. That's 2 times 2 of hydrogen, and that's the same as the 4 hydrogens over here. Okay, let's have a look at the next thing. Let's look at the oxygens. Now, when we started off, we had only 2 oxygen atoms on this side. Okay, but we've got a problem because we've got 2 here, and we've now got another 2 here because there's 2 lots of water, so that makes 2 there and 2 there, and we've only got 2 here. Well, 2 can't become 4. So I've drawn in another oxygen molecule, and of course that's the answer. What we're going to do is we're going to put a 2 here and have twice as much oxygen, and that will make 4 oxygens on this side and 2 plus 2 on this side. That's 4 on this side. So now it all balances up. Okay, there's the answer. CH4 plus 2 O2 goes to CO2 plus 2 H2O. Okay, let's have a look at another one. This time we've got barium nitrate, and there's 2 nitrate ions. We've got 1 barium here, okay, fine, but there's 2 nitrate ions, and the way we draw that is, the way that we write it is we put a 2 here to say there's 2 of those. And down here you can see in the diagram, in the picture, we've got, well, there's the barium there, right, and the nitrate, there's 1 nitrate, but we've got another one over here as well, 2 nitrates. That's what that 2 is for. Let's look, okay, we can draw, we can actually, we can do the little video. There we go. That's barium nitrate. And this one here is the potassium sulfate. The potassium is the two big things on the outside, and the sulfate is the ion that sits in the middle. These are not molecules, these are ionic substances. Okay, so the product, of course, is potassium nitrate and barium sulfate. So once again, I can show you how that might look if you imagine what potassium nitrate would look like, maybe something like that, with a big potassium ion and a nitrate ion consisting of one nitrogen in the middle and 3 oxygens on the outside. And barium sulfate, it's good to imagine that as well. There's a barium ion, and next to it is a sulfate ion. Sulfate ion's got 1 sulfur and 4 oxygen atoms attached to it. Okay, so when we go to solve the problem, we need to count up all the different things. Here we've got 1 barium, that's fine, and 1 barium, no problem there. We've got nitrate ions, NO3, and we've got 2 of them here. And over here we've got nitrate ions, but we've only got 1 of them. That's not the right number, we need to have 2 of those. So what we're going to do is we're going to put a 2 here, like this. We've got 2 potassiums over here, and look, by putting this 2 here in front of the potassium nitrate, that means that we've got 2 potassiums as well. So we've got 2 on both sides, and 1 sulfate here and 1 sulfate here. Now, in case you don't like working with ions like nitrate and sulfate, we can just do the atoms in the usual way. So barium, we've got 1 here, we've got 1 here. Let's do nitrogen. Okay, so there's 2 lots of nitrate. This 2 here tells there's 2, so that means there's 2 on this side of nitrogen, and this 2 here tells us that there's 2 lots of nitrogen here. So N on this side equals 2, so it balances up. That's good. Just better put that 2. Let me put that 2 in there. There we go. Now where were we? We're going to do oxygens. So we've got 3 oxygens here, but there's 2 lots of them, 2 lots of 3. So that means oxygen over here equals 6. Oh, plus we've got these ones here, there's another 4. So I better add that on as well. And that gives us some oxygens on this side. We've got 2 lots of 3 here, so that equals 6. And plus we've got another 4 here. That's another 4. So that means 10 on this side and 10 on this side. They're both the same. So we've done the barium, we've done the nitrogen, we've done the oxygen. Let's do the potassium. I think you can see it's going to balance out because we've got 2 on the left and we've got 2 on the right. We haven't done the sulfur yet. 1 sulfur here, 1 sulfur here, so that's good. And we've already done the oxygen. So that's how you do it. You add up the atoms on one side and you add up the atoms on the other side, and you just change the coefficients. Now you can't change the little numbers down here, you can't change these numbers because you can't change these numbers here because these are the formulas of the compounds. We're not going to change the formula of the compound. What the compound is, that comes out in the reaction. We can't change that. What we can change is how much we think that there is, and so that's the number we change there. Okay, so I've got some for you to do. There's 10 of them. Going to get it to come up. There we go. You might find some are pretty straightforward. You might find some are a bit more difficult. I can't guess which ones you'll find easy or not easy, but I want you to try all of them and email me. Tell me what your answers are. Email me your questions and I'll get back to you. Thanks.